So chapter 2 is kind of completely different from chapter 1. I don't know that we'll do a single operation with a set in chapter 2. I don't think we do. Maybe something sneaks up on me, but I'll just jump into it. The beginning of chapter 2 is kind of with geometry. We're going to start off section 2.1 doing the Pythagorean Theorem, and then we're going to do like area, volume, perimeter, and it's a friendly chapter. So the Pythagorean Theorem is a theorem that most students could quote. The Pythagorean Theorem itself is a squared plus b squared equals c squared. And real specifically, the Pythagorean Theorem is a relationship between the sides, the length of the sides, in a right triangle. So the Pythagorean Theorem only is applicable to triangles, and even more specific, it's only relevant to triangles that have a right angle. A right angle is a 90-degree angle. A lot of times when we draw a triangle that has a right angle, we put a little, I don't know, half a rectangle in the corner where the right angle is. So this is a typical right triangle, but it's not the only right triangle. I can draw an upside down right triangle, and the Pythagorean Theorem would hold for it. So here's another right, at least as right of a triangle as I could make, and here's the right angle. When we go to use the Pythagorean Theorem, it's something we can use to find the length of the sides in a right triangle. I need to know 2 of the 3 lengths, and one of the names is absolutely inflexible. That's the side that we're going to call C. If I can identify the right angle in the triangle, the C is the side opposite the right angle, and this C is called the hypotenuse. So in the 2 triangles I have drawn, theirs would be the C. Let me draw another right triangle real quickly here. So here's the third right triangle. Here's the right angle. Opposite the right angle has to be the C. The sides that you call A and B, they're a little more flexible. It kind of really doesn't matter which side you call A and which side you call B. I imagine I'm not consistent as I go through and do my problems. These I'm going to call the legs of the right triangle. And the legs of the right triangle, it doesn't matter what you call A and what you call B, but for this triangle, I labeled the length of the vertical side A, the length of the horizontal side B. It doesn't matter. I'm not going to consistently make the vertical side A and the horizontal side B. I'll probably change from time to time. So the C is inflexible, but the other sides A and B are absolutely flexible. So as you're going through your work in this section, if I ask you to find the length of the sides of the triangle and you choose an A when I chose a B, it doesn't matter. So the opposite sides, the sides that are next to or adjacent to the side that has the right angle, it really absolutely doesn't matter which one you call A and which you call B. So that's kind of everything on the first page, probably a lot of which you've already known. So, example, name each side of the triangle. That is, name one side A, one side B, and the hypotenuse C. The only side I don't have flexibility on is the hypotenuse. So in this particular problem, the hypotenuse is going to be C. So the instructions here said label one side A, one side B, and one side C. I'm going to say the C has to be 5. And it would be nice if this triangle had units on it, like if that was like 5 inches or 5 centimeters, but it doesn't. So I'm just going to say the C is equal to 5. And then the 3 and the 4 are interchangeable for A and B. It would be completely fine to say A is equal to 3 and B is equal to 4. But it would be equivalently correct if somebody asked you to name the sides of the triangle to set up for using the Pythagorean Theorem. If you said A is equal to 4, B is equal to 3, and C is equal to 5. It's the C that's not flexible, but the A and the B, the sides that are adjacent or next to the right angle, or that contain the right angle between them, those are flexible. Now we'll do an example where we actually use the Pythagorean theorem to find the missing length of a triangle. And in this chapter, units are going to start to become important, and it's going to be the first time now the units are going to be important. So the example here says, find the length of the missing side, round to 2 decimals, make sure to use proper units in your answer. So this side right here, I know a value for the 2 sides of the right triangle that are adjacent to the right angle. The missing side where this question mark is, I'm going to call this missing side C, and I'm going to use the Pythagorean theorem to figure out what C is. Because C represents the length of a side in this triangle and the lengths are given in centimeters, when I go to write my answer to say the missing side is, I'm going to include the unit centimeters. So I'm going to use the formula a squared plus b squared equals c squared, and I need to decide which, if I'm calling the 2 an a or a b, and if I'm calling this 4 or an a or a b. And I picked a equal to this 2, I guess, and b equal to this 4. I'm not going to include units in my work, I'm just going to include units in my answer. So to go to find the missing side, I'm going to do a squared, which is 2 squared, plus b squared, which is 4 squared, equals c squared. This is pretty easy math. I'm not going to get my calculator out just yet. 2 squared is 4. 4 squared is 16. So I get c squared equals 4 plus 16. This gives me 20 equals c squared. And then if I know what c squared is and I want to find out what c is, I need to square root both sides. I don't need to use plus or minuses when I'm trying to find the length of a side in a triangle, because the lengths of sides in any triangle always have to be positive. So at this point now, I'm going to follow my instructions and I'm going to round to 2 decimals. If by chance you know how to reduce square roots and you reduce a square root, that's not a bad thing, it's actually a good thing. So on my calculator, I just need to find the square root of 20. So I'm just going to go second an x squared key to get the square root activated, and then I'm going to type in the number 20, and then I'll hit enter or equals. I don't really need to close the parentheses, but I can. I see 4.472. I have to decide whether I'm leaving the 7 a 7, or I'm rounding it up to an 8. When you round to 2 decimals, that's the number in the second decimal position that can change. It's either going to remain or stay. If the number in the third decimal place was 5 or bigger, I would have made this 4.48, but it's not. So I'm going to leave the 7 alone. And now I'm going to attach units. This side is in centimeters. It didn't ask for it, but if you just instinctively reduce that square root, and if you wrote, instead of 4.47 centimeters, if you wrote 2 square root of 5 centimeters, I'm completely fine with you reducing a radical. So for the answer to this, the missing side, I'm going to call it a c. I could say it's c equals 4.47 centimeters, or I can say it's c equals 2 square root of 5 centimeters. You don't have to be able to reduce the radicals for this problem, so I'm not going to explain how this calculator did it, but I'm completely fine with a with a radical form as opposed to a decimal form, even though I asked for a decimal form. All right. Another example. Let's find the missing side in this right triangle. Notice that the units are nice and on this one. I don't know how to draw these, so I've searched Google Images to find this. And this side was actually called X, which is kind of unfortunate because the sides in the triangle, they need to be A, B, and C. And so let me try to figure out what this X is equal to. When I get to write my answer to this, my answer is going to say X equals some number centimeters. So I'm going to use the Pythagorean theorem, and to use the Pythagorean theorem to find a missing side, I need to plug values in for A, B, and C, and The side opposite the right angle is always the c. So I already put 20 in here, should be c squared. The side opposite the right angle is the c. On the right side of the equal sign, I need to put 20 squared because that's what the c is. These two sides, one needs to be a and the other needs to be b. I'm going to call this side the a and this side the b. Although when I look down here at how I figured out my answer, I did it backwards. This is because I'm not consistent and it doesn't matter. It doesn't matter which side of the legs you call A and which you call B. So I'm going to call the A x centimeters, and so I'm going to plug an x in for the A and a 12 in for the B. This is a formula that I'm going to need to solve for x. I'm going to do some work in my head that you might need your calculator for. 12 squared is 12 times 12, which is 144. 20 squared is 20 times 20, which is 400. In order to solve for x, I need to isolate the x squared and then square root. So I'm going to minus 144 from both sides. When I do this, the 144 cancels on the left side. It leaves me the x squared all by itself on the left side. On the right side, 400 minus 144 is 256. And just like the last problem, once I get the square term isolated, I square root both sides. I don't need a plus or minus because I'm finding a length, and lengths can only be positive. The square root of x squared is just x. And then the square root of 256 is 16. Again, on this calculator, I would go second and then hit the x squared key, and then I type the number 256. I don't really have to close the parentheses. And the square root of 256 is 16. And I need units in my answer because the length of this triangle are in centimeters. I'm going to attach centimeters to my answer. So the answer to finding the length of the missing side, because it's labeled as x in this problem, I'm going to say x equals to 16 centimeters. Here's another example. Let's find the length of the missing side. It's already worked out for you, but I'll work it out again. So to find the length of the missing side, I have a right triangle, so the Pythagorean theorem of a squared plus b squared equals c squared holds just fine. The c is the side opposite the right angle, so in for c, I'm going to plug 6.2. I'm going to leave the squared there. The a and the b are interchangeable. Let me call this side a and this b, but you can switch and get exactly the same answer. If I called this side a and that side b, what I'd plug into my formula is 4.9 squared, and then instead of b squared, I'm going to write x squared. And now I'm going to need my calculator to get some of the work done. So on the left side, I need to figure out what 4.9 squared is. So I hit 4.9, then I hit the x squared key. And 4.9 squared is 24.01. On the right side, I need to know what 6.2 squared is. And 6.2 squared is 38.44. Just like the last problem, I need to isolate the x squared term, so I'm going to minus 24.01 from both sides. On the left-hand side, the 24.01s are going to cancel. It'll isolate the x squared. And on the right-hand side, I need to do 38.44 minus 24.01, and I get 14.43. And now I'm going to square root and round to 2 decimals. On the left-hand side, when I square root, I get x. On the right-hand side, I hit second and then the x squared key, and then I type my 14.43. And I see 3.798, and it's either going to be the case that this 9 is going to stay a 9 or it's going to round up to a 10. Because the number after the 9 is 8, which is bigger, 5 or bigger, I'm going to round the 9 up to a 10. So I'm not going to worry about this 8 in my answer. This 9 is going to round up to a 10. I'm going to carry the 1 over from the 10 and round the 7 up to an 8. So I'm going to say this is 3.80, or just 3.8. And the units of the sides here are in meters. So I'm going to say it's 3.8 meters for my answer. But I don't really need to have that second decimal because the second decimal is a 0. it would be equivalently okay to say that missing side is 3.8 meters, or 3.80 if you want to do 2 decimals. I'm just kind of not showing or talking through the work that I've typed up because I'm doing the actual work. So, in this problem, it says find x, be sure to include units. So there's 2 different triangles here, and each triangle has an x. These are similar triangles, actually equal to each other. The first triangle that I highlighted in pink has sides x centimeters, 10 centimeters, and 8 centimeters. The second triangle that I'll highlight in green has sides of 8 centimeters, x centimeters, and 10 centimeters. Both of these have right angles that are assumed but not shown with little brackets, and I believe both of these triangles I'm going to get the same value for x. It makes sense. It's the same problem. An x can't have multiple values. So for both problems I need an a, b, and a c. In both triangles, this triangle, the c is across from the right angle. This I'm going to call the a, and this I'm going to call the b. In the second triangle, the c is opposite the right angle. I'm going to call the x the a, and the 8 the b. And if you'll notice what I've done, I've forced the work to come out the same. For this triangle, I would go x squared, which is a squared, plus b squared, which is 8 squared, equals c squared, which is 10 squared. And in the blue triangle, I'd start off doing a squared, which is x squared, plus b squared, which is 8 squared, equals c squared, which is 10 squared. Each of these is exactly the same computation, so I really only need to do one of them because I'll get the same answer. Let me do the blue one because I have a little more room. So I can go x squared plus 8 squared. 8 squared is 64, equals 10 squared. 10 squared is 100. Isolate the x squared term by minusing 64 from both sides. This will give me x squared equals to 36. Once I have the x squared isolated in the Pythagorean theorem, you square root both sides. On the left-hand side, the square root of x squared is just x. On the right-hand side, the square root of 36 is 6. So when I go to write an answer to this, I need to put units, and each of the lengths are in centimeters, and I'm finding the length of the side, so that my unit should be centimeters. And the number is 6 for both of these x's. I don't need to write both x's down. I'm just going to say x equals 6 centimeters and just write 1x as opposed to 2. Even though it's actually rectangle, even though the rectangle has 2 sides, I don't have to write the x down twice. There's only one value for x. All right. Example, find the height of the triangle. That is, solve for h. Round your answer to 2 decimals. Make sure to put units in your answer. So inside this triangle, there's 2 triangles. There's a left triangle that looks like this. And there's a right triangle that looks like this. That left triangle, I picked out the h and the 4 from the triangle, and it only has 2 sides labeled. This opposite side would be a c, I guess, because I'm assuming this is a right angle. And the right triangle, it has a height, a 4-foot side, and an 8-foot side. My goal is to solve for h. I can use either of these 2 triangles to solve for h. I'm going to use this one because it actually has numbers for 2 of the 3 sides, and I need that. In this triangle, when I go to attack it, I need to pick out an a, b, and a c. And the right angle is there. The side opposite the right angle is the c. So I'm going to make the c 8 feet. These sides are interchangeable. It doesn't matter what I call a and what I call b. Let me call the 4 the A and the H the B. And for my Pythagorean theorem, I'm going to do A squared plus B squared equals C squared. And for A squared, I'm going to plug in 4 squared. Instead of B squared, I'm going to write H squared. And instead of C squared, I'm going to write 8 squared. So this is going to give me 16 plus H squared equals to 64. I'm going to minus 16 from both sides. This is going to give me H squared equals to 48. And then I'm going to square root both sides. On the left-hand side, the square root of H squared is just H. On the right-hand side, when I square root the 48, I see 6.928, and then I have to decide whether the 2 stays a 2 or if it rounds up to a 3. The number after the 2 is an 8, which is 5 or bigger, so I'm going to round up to 3. In my answer, I'm going to put 6.93. It's the length of a side, so I'm going to put feet down. That's all I was asked to do for this problem, is to figure out what h is. If you just instinctively know how to reduce square roots, and if you would have written h equals 4 square root of 3 feet, because you just instinctively, when you reduce square roots, you don't throw them into decimals, I don't have a problem with that. Although the instructions say round to 2 decimals, so that's kind of what my key would have for this problem. But you don't have to if you want to put a reduced radical form of the answer. Finally, to the homework problems. All right, so problems 1 through 20. Use the Pythagorean theorem to find the missing length. Round to 2 decimals. When necessary, make sure to use units in your answer. I'll let you use E. Do 1. I'll do number. I'll do the same problem, essentially. So when I do problem 2, it gave me an A, it gave me a B. I need to find the C. So when I go to do problem 2, I'm going to use the A squared plus B squared equals C squared formula. And for A squared, I'm going to put 12 squared. And for B squared, I'm going to put 5 squared. I'm going to leave the C squared alone. This is going to give me 144 plus 25 equals C squared. This gives me 169 equals C squared. And then I square root both sides. This is going to give me 13 equals to C. My answer needs to have the units. My answer to number 2 is going to be C equals 13, and my units are going to be centimeters. That should be exactly the same answer that you're going to get for number 1, because your missing side doesn't have a name on it. You might as well name it C, because that seems to be the appropriate name. Let's move on to 3 and 4. I don't think I need to do your problem 3. So pause the video and give problem 3 a chance. In my problem, the side opposite the right angle is the C. The other lengths are interchangeable for A and B. So when I go to do my problem, I'm going to go the side that I call A squared plus the side that I call B, which I'm going to now call X squared, equals the side that I labeled C squared. Got to use my calculator at this point. So 48x squared gives me 2,304 plus x squared equals 60 squared, which is 3,600. Video just hiccuped, so I just paused for a second. Now I'm going to isolate the x squared by minusing 2304 from both sides. This gives me x squared equals to 1296, and then I'm going to square root. So second and x squared, 1296. I get 36. So my answer for my problem is going to be x equal to 36. The units are going to be centimeters. So this is my answer to number 4. Your answer to number 3 is 28 centimeters. It's going to be x equals 28 centimeters. All right. I like your 5 better than my 6. Let's do 5. So 5 is really nice because it gives me the right angle. I have a side to call C. This side is already called A. I'm going to call this side B. And instead of my A squared plus B squared equals C squared, I'm going to use A squared as A squared. For B squared, I'm going to plug in 8 squared. For C squared, I'm going to plug in 12 squared. So this is going to give me A squared plus 64 equals to 144. I need a minus 64 from both sides. I'm going to get 80 on the right side, so this is going to give me A squared equals to 80. And now I'm going to round to 2 decimals. So I'm going to square root both sides and get A, and then second x squared for the square root of 80. And I see 8.944. I'm either going to leave that 4 at a 4 or bounce it up to a 5. Because the number after it isn't 5 or bigger, I'm going to leave it as a 4. And for my answer to number 5, the number I'm going to put in is 8.94. The units I'm going to put in are inches. And again, if you have the desire to write a slick answer, you can write 4 square root of 5 inches. Again, the instructions specifically say round to 2 decimals, so that's kind of what I wanted, but you can definitely give me a slightly different number. So each of our next problems give us a square or a square or a rectangle and ask us to find the length of the diagonal. When you go to do your problem 7, you're going to need to find the length of the diagonal, and let me call the diagonal D. This is the length that you're trying to find. And when you go to do problem 7, you need to, from that square, pull out a triangle, and the triangle you're going to work with is going to look like that. For my problem 8, I have a rectangle as opposed to a square. The diagonals have equal lengths, so I'm just going to find the length of this diagonal that I just highlighted. And both diagonals in a rectangle have the same lengths, so I'm going to use this triangle. I'm going to find that diagonal. My right angle is here, so I'm going to call this side A, this side B, and the diagonal C. And when I go to do the Pythagorean Theorem, I'm going to do A squared, which is 15 squared, plus B squared, which is 8 squared, equals the C squared, which I'm going to write diagonal squared. And now this is going to be 225 plus 64 equals D squared. That gives me 289 equals D squared. So now I'm going to square root. I think that's 17. And even though my instructions say round to 2 decimals, I'm not going to need to show those 2 decimals because this is a perfect number. So my answer is going to be the diagonal, or D would be fine. And then 17 is the number, and my units are centimeters. Your problem should work very similarly, other than you're going to get a decimal answer. And for number 7, I came out with 14.14, and the units were meters. All right, not that you need me to work 9 with you, but 10 doesn't need rounding, 9 does. Let me figure out the length of the diagonal. I have the diagonal labeled as x, so I'm going to leave it as an x. I need to pick a side to call A and a side to call B. I have a right triangle that's here, and the diagonal is the C. So in problem 9, if I'd use Pythagorean Theorem, I'd go A squared, which is 36 squared, plus B squared, which is 18 squared, equals C squared, which is going to be x squared. And then I pull out my calculator and do 36 squared and 18 squared. So I'm going to get 1296 squared plus 324 squared. That's going to give me 1620. Let me clean this up a little bit. So this comes out to be 1296 plus 324 equals to x squared. And I just added those on my calculator, so that gave me 1620 equals to x squared. And now I'm going to square root. The square root of x squared is just x. And then on the right-hand side, left-hand side, the square root of 1620, I see 40.249. I have to decide whether I'm leaving that 4 at a 4, I'm bouncing it up to a 5. The number after the 4 is 5 or larger, so I'm going to round it up to 5. And then for my answer, because that side it has a name, I'm just going to say x equals to 40.25, and then I'm going to write meters. And again, if you like prettier square roots, if you gave the answer 18 square root of 5 meters, that's completely fine. I put an x next to my answer because the side is labeled with an x as opposed to making a D to stand for diagonal. All right, when you go to do problem 11, you're going to have to make an assumption that, so we're going to try to extract a triangle. My goal is to solve for x. The x is the length of the height. And you're going to need to create a smaller triangle from the bigger triangle. And the triangle that I might suggest is the triangle that I've just drawn. And you're going to have to assume, because this is an isosceles triangle, that the height breaks the base up into two equal sides. You're going to have to assume in your triangle that this length of 10 is broken up into 2 equal 5. So the triangle that you're going to need to work with as you go to do problem 11 is this triangle. You're just trying to solve for x, so you only need one triangle to do that. My problem 12 says find the height of the triangle. This is the height. The height of a triangle is the length of a side that goes from one of the corners to the opposite side that makes a right angle. So I'm going to need to find a height. And the triangle that I'm going to need to focus on to find the height of the triangle is that. And so I'm going to focus on this triangle that has lengths of 3, 5, and h. I don't see any units, so when I go to write my answer, I'm going to write the word units next to it because I don't see a length. Your problem, it doesn't have the lengths, the measurements, the meters on there, but it says assume the lengths are in meters. When you go to write your answer for problem 12, you should put meters in there. So you're going to go x equals something meters. And on mine, I may just do the same thing. I'm going to say assume units are meters. So if I can't find a picture that I like online, I don't know how to make these. I don't want to draw them by hand. So I just pick something and then I add the assumption here. So let me do these. This side is across from the right angle. It has to be a C. I'm going to call that an A and that a B. And I'm going to go 3 squared plus plus height squared equals 5 squared. This is going to give me 9 plus the height squared equals 25, and then minus 9 minus 9. This gives me the height squared equals 16, and then square root. I'm going to get the height equals to 4. I'm going to just say height equals for my answer. I could say h, it would be fine because h generally stands for height. But since I was asked to find the height, I'm going to say the height equals 4, and then I'm going to put these units on that I kind of snuck in after the fact. All right, just in case you don't know your answer to number 11, your answer should be 10.91 meters. Two more problems left to do. and they're kind of ugly. So let me work through 13 with you. So for 13, it asks me to find little d and big D, and it gives me a box essentially. To do your sides, to find little d, I'm going to look at this triangle right here, and so let me try to talk through this because it's tricky. So because of the distortion right here, that doesn't look like a right triangle whatsoever. This corner, the corner is that bottom right here is supposed to be a rectangle. So if I just blew up the bottom, let me just take the bottom and blow it up. Not in a 3D drawing. That bottom is really supposed to be this. So this, what I just drew in pink, this is, I'll call this the bottom. That bottom is supposed to be a perfect rectangle. It kind of gets distorted when you draw three-dimensional. And then the legs are supposed to be 9 feet and 9 feet. That little 1 mark would mean feet. If you had 2 dashes, it would mean inches. And then I'm looking for a little d. So to find little d, I'm going to go a squared, which I'm going to call 9 squared, plus b squared, which I'm going to call 9 squared. This d is a c because it's opposite the right angle. These are interchangeable for a and b. So I'm going to go 9 squared plus 9 squared equals little d squared. This is going to give me 81 plus 81 equals little d squared, and 81 plus 81 equals 162, so I get 162 equals little d squared, and then I'm going to square root, so now I'm going to do second square root of 162. I see 12.727. This 7 is going to cause that 2 to round up to a 3. And I'm going to write 12.73 equals little d. Part of my answer is going to be that, but I need units, and my units are in feet. So as I go to write my answer, I'm going to say little d equals 12.73 feet, or I could use a little mark. Now I need to find big D, and to find big D, I need to look at this triangle right here. Let me try to draw that triangle down here. So I've got this. And again, it doesn't look like a right angle, but if I straighten that out, that triangle looks like this. If I cut it out and put it down here, it would look like that. And the little d part of here's the little d, and the little d is going to be 12.73. The other side here is 9 feet, and then the big D is what I'm trying to find. So in this pink triangle, the big D is my C, and these are my A and B's, and they're interchangeable. Let me just do a different color because I'm running out of room here. So I'm going to find the big D, I'm going to do 12.73 squared plus 9 squared equals big D squared, and this gives me 162, I'm just going to keep all these decimals, 162.0529 plus 9 squared, which is 81, equals D squared. If I round that to 2 decimals, I don't think that's going to impact my final answer, but usually we only round once we get to an answer. Let me do this now, 162.0529 plus 81 on the left side. The left side becomes 243.0529. The right side is D squared, and then I square root both sides. So now I'm going to do second square root of 243.0529, and I'm going to round to 2 decimals. I get 15.590 equals to D. That 9's going to stay a 9, and I'm going to write 15.59 equals to D in my answer, big D in my answer. And of course I need units, and the units of this for that problem are feet. I can make the little prime kind of complement symbol, to call something feet, or I can write feet. All right, so one more problem to go. And it's kind of the same problem again. And so if you want to pause the video and try to do 15 by yourself, it would be great. If not, I'll do it with you. And there's two sides that I need to get, and I think I need to get the bottom side first. So the first thing, I'm going to do 15 as opposed to 16. I'm going to go through and try to find C. And again, this base of this is a rectangular base. If I took that base that I just drew in pink and transferred it down here, this is supposed to be the bottom of this. It's a rectangle, and that angle between the 6 and the 8 is supposed to be the right angle. They're supposed to be the right angle. The sides from the bottom are 6 inches, 8 inches, and C. So first I'm going to find C by taking the bottom of this rectangular box and figuring out what C is. So I'm going to go 6 squared plus 8 squared equals C squared. This is going to be 36 plus 64 equals C squared. This gives me 100 equals C squared. And then I square root and get 10 equals to C. Part of my answer has to have that C, and it needs to have units. The units are going to be inches. Now I need to find the D, and the D is on this triangle. And let me just try to show you what that triangle looks like in perspective. So it goes So if I took this triangle, cut it out, and put it down here, this is what it's supposed to look like. It has a 10, a C, and a D. And the right angle is supposed to be right there. And that D is actually a C, and this C is that C, and that C is 10. So this triangle, although it's completely lost perspective, is a 10 by 10, and then D is the length of that diagonal. So let me try to find out what that D is by using the Pythagorean Theorem. I'm going to call that A, that B, and that C. I'm going to say 10 squared plus 10 squared equals to D squared. That's going to give me 100 plus 100 equals to D squared. That's going to be 200 equals to D squared. And then I'm going to square root. And when I square root, I'm going to round it to decimals. So second square root of 200. And I see 14.142. I'm going to leave it at 14.14 because that 2 doesn't force me to round up. When I go to write my answer, I'm going to say D equals 14.14 inches. I have the answers off to the side. I've checked. I know my answers are right. So I think I'll just stop the video there. On the test, I don't have any of these box problems. I mean, they're kind of fun, well, interesting to do. On the test for the Pythagorean Theorem, I just have the nice flat triangles as opposed to triangles that are buried inside a cube of some sort. So that's everything for this section. And then so the next section's there's a little more to it. The videos kind of get long, so make sure you have a good amount of time before you start the next section.